Hello, algebra students. Welcome to another day of notes. Today we're going to be talking about intercepts of functions. So let's go ahead and define it. X and Y intercepts. These are the points at which the graph intersects the axis. So the points at which the graph intersects the axis. That runs off a tiny bit. So we have two different kinds, x-intercepts, y-intercepts. So x-intercept, this is the value of x when y equals 0. It's where the line crosses the x-axis. The y-intercept is the value of y when x equals 0, where the line crosses the y-axis. Now, x-intercepts have many names, okay? So they can also be called zeros, solutions, and roots. Okay, so again, not to make anything any more confusing than it needs to be, the math world decided that x-intercepts have all of these different names. So you'll see it as x-intercept, zeros, solutions, etc. Okay, let's go ahead and get started. When you are given the graph, I'm going to have you guys write down both the x and the y-intercepts, okay? So we'll start with number 1. What the x-intercept is where it intersects that x-axis. So it's right here, and that is 2. Then we have y. Well, this one is graph didn't quite work out so well, so we're going to fudge this one. Let's say it intersects, I don't know, what do you want to say, 5.5, 6? Let's go with about 5.5, okay? So every once in a while we'll fudge a little bit here at the beginning of this. Later on in the year, you'll figure out how to get more specific with our answers. And you know what? I wrote down 5.5 when it should be negative 5.5. So anyone else catch that typo? There we go. Fix that real quick. All right, number 2. Number 2, we'll start with our x-intercepts where it intersects that x-axis. And so this time there's more than one, so we're going to write this as a solution set. And so it is negative 2, 1. Then our y-intercept. Our y-intercept, oh, you know what? Again, I'm going to fudge just a tiny little bit. Let's go ahead and do maybe 1 and 3/4, so 1.75, okay? Or you can write it as a fraction. Let's go to number 3. So for number 3, we'll start with our x-intercepts. And so, again, we'll fudge a little bit. I'm going to start with my lowest one. And, these lines are messed up. It's right here and right here. So we'll go and call that one negative 3 and then positive 4. For y, again, we're going to write this as a solution set. We'll start with the bottom one. And so the bottom one, I think it's this one right here. And so we'll go ahead and call that negative 6. 1, 2, 3, 4, 5, 6. Yeah, negative 6. And then 1, 2. We'll go up to 2 on that one. Okay, number 4. Before we go on number 4, did you guys notice number 3 is not a function? 1 and 2 were functions, but number 3 is not. Number 4, what do you guys think? Is this one a function? Hopefully you're saying yes. So for this one, again, x-intercepts where it intersects the x-axis. We're at negative 3, positive 3. Our y-intercept is right here when y equals 0. Perfect. Let's go ahead down to number 5. Number 5, the x-intercepts here. Again, we're writing as solution set since there's more than one. There are 2. These zeros, so it is negative 1, 4. And for y, my y-intercept, we'll call that negative 2. And then we'll do 6 together next time I see you in class. All right? And so we'll move on. We'll turn the page. Mine don't want they're stuck. Here we go. Second page. What is the y-intercept of the function? Again, notice that there is only one y-intercept where it intersects that y-axis. Y equals 3. Now, a really great question. Explain why a function cannot have more than y-intercept. So, a function. So we have to remember we want to make sure that this is a function. If it, let's say, had another y-intercept, let's say if it was all the way down here. Okay, if a function had more than one y-intercept, then it would have more than one output for the input, and then it would make it not a function. Okay, so let's go ahead and write that down. So if a function, so we're restating the statement or the question, had more than one y-intercept, then it would have more than one output for an input. Then it would not be a function. And this is a key concept, okay? So really, when you see that you have not even the graphed line, but you see that it has one y-intercept, you know, that right there clues you in that maybe it is a function. But if you see that a graph line has two or more y-intercepts, then that should clue you in that you are not working with a function, okay? Let's go ahead and give the y-intercepts of this function. So again, this is where it intersects that x-axis. There are two, so we'll go ahead and write this as a solution set. The solution set of this one is going to be -7 and -5. We're going to, I don't know if you noticed on the first page, we did write all of those in decreasing to increasing order. So we're going to follow that same pattern that we are doing for domain and range and everything else that we're writing. Okay, so let's go ahead. Here's another one. What are the x and y intercepts of the function? We're going to list each of these as an ordered pair. Okay, so as an ordered pair, again, starting from left to right, I have -7, 0. Again, keep going left to right. This one is now -5, 0. Now I'm at -1, 0. Okay. Then I am now at 3, 0. And the last one is 5, 0. Okay? My y-intercept, just the one. We're going to write it as an ordered pair. Okay? 0, 3. Okay? So just a reminder for these intercepts, when it lies on the line, the other coordinate is 0, okay, so depending on which line, x-axis, y-axis, okay? All right, and then the last thing that we're going to do today is learn how to find these intercepts algebraically, okay? And so when I ask you to do it algebraically, make sure you're showing the work. And so for the x-intercept, this is a value of x when y equals 0. For the y-intercepts, the value of y when x equals 0. So this is a substitution. We'll put 0 in for y when we solve for x, etc. So let's go ahead and start with the x-intercept. So remember that f of x is also, and I'll write that right here, remember f of x is the same thing as y. Okay, so let's scoot this paper. I'm going to put 0 in for f of x and solve for x to find my x-intercept. I'm going to go ahead and add 8 to both sides. When I do that, I have 8 equals 4x. Divide both sides by 4, x equals 2. So a little shortcut. Now let's go ahead and solve for our y-intercept. So again, f of x equals y, so I'm going to put y in for f of x, and then I'm going to write this as 0 in for x. When I solve, 4 times 0 is 0, so y equals -8. Let's go ahead and try the next one. So for the next one, same thing. We'll put 0 in for f of x, which is our y. And then we're going to solve for x. My first step, I'm going to subtract 7 from both sides. So I get -7 is equal to -x. Divide both sides by -1. X equals 7. And so my next one, instead of writing f of x, I'm going to write y. And I'm going to put 0 in for x. And so y is equal to 7. Okay. Now moving on to number 3. For number 3, I'm going to, again, put 0 in for y, which is my f of x, and then solve for x. I'm going to subtract 2 from both sides, so I have negative 2 is equal to 1/2 x. From here, to keep solving for x, I'm going to multiply both sides by 2. So I'm going to just show that here real quick. I'm multiplying both sides by 2, and so I have x is equal to negative 4. And then to solve for my y-intercept, I put 0 in for x. 1/2 times 0 is 0, so y is equal to 2. We'll do 4 next time I see you in class. Number 5, just a little bit of a different form. We're going to be doing the same thing where I'm going to go ahead and put 0 in for y. When I'm solving for x, 2 times 0 is 0, so I have 3x is equal to 4. I kind of jumped ahead there on that one. I have 3x equals 12, and so x equals 4. My hands are working faster than my mouth. Anyway, so for solving for the y-intercept, we're going to put 0 in for x, and then solve for y. 3 times 0 is 0, so I have 2y is equal to 12, and so y is equal to 6. And we'll do 6 next time I see you in class. Now this last page, we probably won't do all of these next time I see you in class, but we're going to do this together in class because we're going to be using technology. If you don't have a graphing calculator, no worries. Make sure you have your Chromebook. We're going to be using the graphing calculator from Desmos, so desmos.com. And so I'll be teaching it that way first, and then I'll teach it with those of you that have a graphing calculator. And so later on in the year, we'll have opportunities where I have extra graphing calculators. Everyone can use it at that time. Okay, hey, that's it for these notes. Thanks a lot, guys. May the force be with you.